This is the overview for the chapter. It's not a long chapter, and really these last two, this one, 6.5 and 6.1, they're all with graphing, and we do them with the graphing calculator or Desmos. So those are not going to be that difficult to do. The substitution, the only reason why I'm doing 2 days on substitution is because we'll do it on Tuesday and then we have a 5-day break and then we'll come back. So I'm just going to give a refresher on the substitution when we get back on that Monday. The elimination, it's not hard. It's just, I think it should be broken up into 2 days. And then your special systems, those are ones where you have parallel lines or coincident lines. So it's not that it's hard, it's just different information. So we're going to move on to solving systems. What's a system of equation? It's just, huh?
I said Mrs. Reed.
Yeah.
Hayden and Braden joined.
Okay. Hayden and who?
Braden.
Oh, Braden, you're early.
No, Braden Rapido.
Oh, Braden Rapido.
Yeah,
there. Okay. I missed him. Okay. Is Jake there? Or Hayden?
Hayden.
Hayden is. Jake is not. Okay. Okay.
Yeah.
All right. So system of equations are just two or more equations that you want to find a solution for. A solution is where the two graphs cross each other or their intersection. So if you have parallel lines, the two equations will not have any solution. And if you have coincident lines, those are lines that are right on top of each other, you'll have an infinite number of solutions. So when you have two lines, a solution occurs when you have more than two lines. So if you have 3 lines or 4 lines, a solution occurs when all the lines intersect in a single point. So you won't have two solutions because 2 lines intersect one place and another 2 lines intersect another place. They all have to intersect in the same place in order to be a solution. So let's look at these 2 equations. Find the solution to these 2 equations. I am going to go into Desmos to write those 2 equations and graph them out. Negative 2x minus 1 and x plus 5. So our point of intersection would be negative 2, 3. So how do I know that negative 2, 3 is really my solution to this? Well, once I get the solution set, I'm going to come back and to prove it, I'm going to put that point in there, negative 2, 3. So I'm going to substitute it into the first equation. 3 equals negative 2 times a negative 2 minus 1. Negative 2 times negative 2 is positive 4, minus 1 is 3. So it works for the first equation. We plug it into the second equation. 3 equals negative 2 plus 5. 3 equals 3. It checks out for both equations when we put that in for the x and that in for the y. Solving this system, once again, just go back to Desmos, type those in.
I have a 10 o'clock sector appointment for guys walking.
1/3. x minus 3. And this one I'm just going to type in as I see it, 2x plus y equals 4. Notice I didn't even have to solve for y on that one, because in Desmos it just
So the
takes
fraction would go like 0.333 or something.
Yeah, it's what I mean. It would calculate it out. That would be the slope, so it would use that to up 1/3. So, but point is you can either type in the line if it's already set y equals, you can just type it in without the y. If you have it where it's not set equal to y yet, you can just type it in with the y in there, and it will graph it for you. You don't even have to solve it for y. So if I wanted to know what the y-intercept of the purple line was, I'd say, oh, given this equation, I can just type it into Desmos and say, oh, it's 4 and my slope is down 4/2. My slope is 2, -2. So my point of intersection for this one would be 3, -2. And they want you to check your point of intersection, make sure that it works. So we come back and we say 3, -2. Does that work in both of them? Does -2 equal 1/3 times 3 minus 3? 1/3 times 3 is 1. 1 minus 3 is -2. So it checks out for that equation. 2 times 3 plus a -2 equals 4. 2 times 3 is 6 plus a -2 equals 4. It checks out for that one. So we're using the graph to find the point. We go back and we check the point into both equations and make sure they work. The biggest thing for you guys is translating these equations into, or these story problems into equations. So Video Club A charges $10 for membership, $3 per month per movie rental. So the total cost, Y, for Club A, total cost is equal to $10 for the membership plus $3 per the movie rental. Club B says it charges $15 for the membership and $2 for the movie rental. So we could take those two equations, go back to Desmos and find out where they intersect. And plus 3x and 15 plus 2x. Now I can't see where the intersection is, so I come over to my settings and I change my y-axis. So 0 to 30. And I can see that it intersects here. What is that on my x-axis? That's 5 down here. You can see it. Oops. 5, 25 would be my solution.
Couldn't you just put that into the y equals and then look at the table?
You could. Yep.
Would that be an easier way to do it?
It could be. It just depends on, what do you find easier, looking at a table or looking at a graph?
Okay.
Our graph doesn't have like numbers on it. So
You mean on your calculator?
Yeah.
Yeah, so it's a little bit harder on your graphing calculator to do it. So yeah, you could look at your table on your graphing calculator and that would probably help you out on there.
And how would we do that on our calculator, what you just did to make it so we can see where it crosses?
Let me pull up this. Just come down here and type. Yeah, sure am. Okay, so when I type in the 10 plus 3x, yeah, 10 plus 3x. And then 15 plus 2x. And I graph it. Okay, so we don't see that, so you go to Window and you change your y min to be 0 and your y max to be 30. And you can do a scale of 5 if you want. Now your x's are scales of 1, 1, 2, 3, 4, 5. And you can't see that exactly, but that would be 25, 5, 25 there. But if you went and changed your mode, oops, and you traced along there, you could get that value. I wanted to trace. Wrong way. You'd have to put in the, even with this, there you're gonna have some issues with the rounding and stuff of your pixels. So you may not be able to get it as easily as on this as you could on Desmos. But you could also zoom in. Let's do a Z box. The box allows you to use your arrow keys to set a corner, and then you hit enter, and then if you arrow down and over, you get the opposite corner of the box, and then it puts that in there. I didn't do a very good job of drawing a box, but just arrow down and see where those X and Y coordinates are. And you can get a little bit closer to the actual answer when you switch back and forth between the lines. You're pretty close to the same values there. So that's all there is for this, guys.
Yay.
I know what your assignment is. Page 386. 386, 5 through 17 all, and 23 and 24. Questions?
No.